Hello students, in previous class I had discussed about electric potential at a point due to a dipole. Today's class I will discuss about equipotential surface and the relation between electric potential and electric field. So the name itself defines it. Equi means equal, potential, surface. A surface where all points will have equal potential. So how will we define that? Equipotential surface is a surface where all points will have equal potential. So let us take this example of a isolated positive point charge. So due to this point charge, the direction of electric field will be radially outwards. And suppose I am taking the equipotential surface for this positive charge is a concentric spherical surface. So why will I say the concentric spherical surface is an equipotential surface? See, if I will take the distance of this point to this point and this point to this point, they will be at same distance. As we know, our potential formula is 1 by 4 pi epsilon naught q by r. Since see here q will remain constant, and if r becomes constant, then the potential value will also become equal. So as the r distance does not vary, so we will say that the potential at this point will be obviously equal to the potential at this point. Similarly, for this surface, if I will take any point, since the points are equidistant from this point charge, so the potential at all the points will be same. So I will conclude that the electric potential for a point charge will be concentric spherical surfaces. That is V if I will write positive charge. So what is the equipotential surfaces for this point charge? I will say that these are concentric spherical surfaces will represent the equipotential surfaces. These spheres will represent an equipotential surface, and I can represent the electric field direction like this. So for different configuration, we will have different kind of potential surfaces. So for a dipole, see this is a dipole. So what will be the equipotential surface for a dipole? Negative charge and a positive charge. So the equipotential surface for this will be like this. For this you can go through your book also. So the equipotential surface for a dipole will be like this. Now let us go for two equal charges having same sign. So if we are having suppose two positive charges or negative charges, then the equipotential surfaces will be like this. And we can represent the electric field directions also. The dipole for this one will be from positive to negative, and here this will repel each other. That means the direction will be like this. So these are the electric field directions. Next, for a uniform electric field. For a uniform uniform electric field, we are representing the uniform electric field like this. So, what is the equipotential surface for this electric field? No, these are the parallel planes perpendicular to the electric field direction. So, at this, if this is the equipotential surface, then at this point all the points will have equal potential. So, we get an idea about equipotential surface, that a surface where all the points will have equal potential. Next, we will discuss about some properties of equipotential surface. So, let us discuss. First one is, no work is done in moving a test charge over an equipotential surface. That means, if we want to move a test charge over an equipotential surface, then there will be no work done. Okay, so let us see. If this is the point charge and the equipotential surface is this, as we know that for the equipotential surface the electric potentials are same. So, if for these 2 points I will write potential at point A is VA and at this point it is VB and the charge is Q. But since it is a equipotential surface, I will write VA is equals to VB. Now again use the formula. What is the formula? No, VA minus VB, the potential difference, is equals to work done by the charge. Then see here, as VA is equals to VB, so this difference becomes equals to 0. So W by Q becomes equals to 0. So the work done will be equals to 0. That means there will be no work done in moving a charge from one point to another point in an equipotential surface, because the surface is having same potential. So this is one property and this is the proof of this property. Next one is, electric field is always normal to the equipotential surface at every point. That means that if we will go for the direction of, or we will go for the angle of electric field and equipotential surface, then they will always form 90 degree. How? Let us see. So this one is the proof for the property, number 1 property. Let us prove for the second property. So according to the second property, the electric field, suppose this is a positive charge, so the electric field direction will be like this. So the electric field is always perpendicular to the equipotential surface. So this is an equipotential surface for this point charge. So this direction, you see electric field direction and the potential, they are making an angle 90 degree. So this will be your property 2, that electric field is always normal to the equipotential surface. For this also you can see, for this direction the potential surface, equipotential surface is making an angle 90 degree. How to prove it? Suppose it is not normal to the equipotential surface, then it will have a non-zero component towards the towards the surface. Suppose this electric field is not normal, it is making some different angle with the surface. If this happens, then we can say there will be a tangential component as well as a normal component. If a tangential component will be there, that means the electric field is present over this surface. And if we will keep a test charge here, then due to this tangential component of electric field, this test charge will experience a force and it will move throughout the equipotential surface. If the electric field is working giving some force, then it will must do some work. But according to our first property, no work is done in moving the test charge. So this is the second proof, that if tangential component is there, then it will move a test charge and it will do some work, which is again contradict to our first property. So the electric field is always normal to an equipotential surface. So this thing is not possible. It will be always perpendicular to the equipotential surface. Next, the third property is no two equipotential surface can intersect each other. If, as we know, if they will intersect each other, then there will be two directions of electric field, which is again not possible. So these are the three properties regarding your equipotential surface. So read it again, and next class we will discuss about relation between electric field and potential. Thank you.